You've come back, minions, have you? Want some more mechanics? Let's do it. What do we have here? First of all, not a big fan of this, but this does happen occasionally in maths world. We're going to go full physics, and we're going to take g to be 10 meters per second. Makes the numbers a bit nicer. Okay, so what do we have? We have a particle p of mass 0.5 kg. Now, it's just hanging at rest here. It's just hanging at rest. It's just chilling at this point here. We don't know where it is. We're going to figure it out in a second. All right, and it's just chilling there. Now, it's attached to an elastic string, natural length 1.25 ms, and modulus of elasticity of 25 ms. Now, what's going to happen is, it's going to get pulled down to a point B, right, and let go from rest. It is then going to go bounce up and down. Now, assuming that the string stays taut, all right, so long as we don't pull it down so far that the string ever goes slack, let's show that it follows simple harmonic motion, period pi over root 10, okay? Then if we're told something about the max K kinetic energy, we're going to find out where B is, and then we're going to find how long it takes to return to B. Okay, all right? But that is so long as the string is taut. So let's have a little look-see at what we've got going on here. So we've got 0.5 g, which is 5 newtons, and we've got tension here, all right? Now what we probably first want to do is we want to find out that distance there, let's call it d. Let's find that distance there, d, before we do anything else, because as I move it down a certain amount x, I kind of want to have a baseline of what my extension is going to be. So let's start with that. So if here at this point here I am just in equilibrium, I'm just letting everything hang and that's where it's chilling, I know that by looking at the forces vertically, I know that T is equal to 5. Now that is equal to my extension, which is D minus 1.25, times lambda over my original length. Okay, so what's that? 25 divided by 1.25 is 20. And I think that D is 1.5. I don't know. It's a day. It's a day. Let's do that anyway. Do you know what? I backed myself. Attaboy, 1.5. So I know that this is 1.5 meters. Okay. Now somewhere in here, right, at some given point, I'm going to be x away from there, right? So let's say P is there with my 5 newtons and my tension back here. And let's say at some generic point in this, I'm x away from there. So this is now going to be my original, that's where I'm going to take my original motion from, okay? So, what have I got? Well, let's take, I don't know, upwards as positive. So what force is going upwards? T minus 5 is equal to ma, which I will use the dot notation, x double dot. Now, what is the tension? The tension is my extension. Well, at this point here, my extension is already 0.25. So my extension here is 0.25 plus x over my original length times 25. Take away 5. And do you know what? I'm going to start, no, do you know what? I can't have a mix of decimals and of fractions. That's just not okay, is it? That's just not okay. People have been arrested for less. So let's deal with this. We've already said that 25 over 1.25 is 20. So that's 5 plus 20x minus... is this the correct way around? But which way am I accelerating? What have I done here? What have I done here? Have I got my things the correct way round? Oh, up is positive. Up is positive. Is that a problem for me? Yes, because x is going downward. So let's take down as positive. Let's take down as positive. That's my problem here. Let's take down as positive, as we always should. There we go. All right, let's just take down as positive. I say as we always should. Now, the reason for this is because I'm thinking of I've pulled myself down, so x is positive going downwards, and that's where I had that going on a little bit wrong. So that's 1/4, so I get minus. Cheeky edit there as we go and find out where I went wrong. And of course I'm being a muppet, I didn't reread the question, the mass is 0.5, 0.5, and there we go. I knew I was out by a factor of 2 there. So that's minus 40x. Now, what this means is we are doing simple harmonic motion because x double dot is proportional to negative x. But we know our frequency is square root of 40, so our period is going to be, which is 2 root 10, all right, which is 2 pi over f, which is 2 pi over f. Is that correct? Period is 2 pi over f, which is pi over, yeah, that works. There we go. Awesome. Lovely. Right. Let's talk energy. Now we've got this, fine, that's lovely. Do you know what? I'm gonna just write that in here. So I've got a record of this. Boop. This is real SHM, not like your funky, what do you call it? Pendulums. Now the key thing is we want the string to be in tension, so we could probably figure that one out. The furthest, now also if I pull it down a certain amount, it will go back up a certain amount, which means the furthest I want it to be here is 1.25. So that's important for us. So that's the max we can get. Now obviously it might not be. Let's have a look. So max kinetic energy, where is it going to have max kinetic energy? Well, I release it from rest here. It has no kinetic energy. Up here is at the top of its motion. It will stop. It will come back down. It has no kinetic energy. So where does it have its max kinetic energy? Here. All right, that is where it has its max kinetic energy. So for part B, let's consider our energy. So let's go energy at B is equal to the energy at O. Now, what is my energy at B? Well, we have, and I'm going to just take that as my 0, just in terms of my gravitational potential energy. It's fine, the math sorts itself out. It's only about change anyway. So what do we have? We have some elastic energy. We have some elastic energy. So how much elastic energy do we have? Actually, I'll take this as my start, that's fine. Elastic energy, well, we don't know what AB is, so let's call this distance here. What should we call this distance here? What should we call it? Little b? He says drawing a D. Well, that bodes well, doesn't it? Let's call it little b. We could just call it OB, in fact, but that just feels longer than I want it to be. So, it's lambda over, L0 over lambda times my extension squared over 2. This is all I have. I just have kinetic energy. Now, what's my extension? Well, at this point, my extension was already 0.25, so it's 0.25 plus b squared. Now, what does that energy get turned into? Well, at 0, what do we have? Well, we still have some kinetic energy, we have some elastic energy. I'm going to stop writing this because apart from anything else, I'm writing it upside down. That is 20, so we're going to get 20 over 2. And at this point, we've already said my extension was 0.25 squared. Right. Well, plus, well, I've now got some gravitational potential energy. There's been a change by how much it is m, let's get this right, g, and the h is little b. And now we have to tidy this up. Now we have to tidy this up. Fine. Let's hope this works. So that is 20 divided by 2, that is 10. And we are multiplying. Let's multiply that out. 1/4 becomes 1/16 plus 1/2 b plus b squared. What's this? That's 10 over 16 from that term, so that's nice, plus 5b. So what do we end up with here? I end up with 5b plus 10b squared. Oh, that's not good. Oh, ha ha ha. Plus my kinetic energy. Right, at this point here I have kinetic energy, which is 2.5. So that is equal to 5b plus 2.5. So that tells me that b squared is 5 over 2 is 1/4, which tells me that b is equal to 1/2. Now if b is equal to 1/2, then ab is 1.5 plus b, which is 2, and that works out nice. Right, so how long does it take for b to return to t? How long does it take? Well, we've established that it's simple harmonic motion with that period. All right, on to part C. Now, bearing what I said earlier is, I said that the longest I could pull it down and make sure the rope remains taut all the way through is 0.25. Right? Because otherwise it will bounce higher than 0.25 and the string will be in compression. Unlucky. But it is what it is. But what this means is, if you see here, we have pulled it down to 2 meters. We have pulled it down here to 2 meters. So we know that B is now 0.5 up to here. So in fact, it will go all the way up here, right, till that distance there is now 1 in terms of the simple harmonic motion. But in this last little section here, in those 0.25 meters, I will not have simple harmonic motion. In those 0.25 meters, I will be in free fall because there is no longer a tension in the string. So we need to be a little bit more careful here. So first thing we're going to do is we are going to figure out what is going on at this point here. Well, all right, so really we want to know what's going on in that time there, because the rest of it, the simple harmonic motion stuff, I know the period of, so that's fine. I know that it will take me pi over root 10 to do that amount of distance. So that's not too bad. What I really want to know is what's going on here. Right. Well, let's find our velocity at that point there. Now, what is our velocity at that point there? All right, so importantly for us, that's 0.25. Our velocity. Well, again, we have that stored kinetic energy. We have that stored kinetic energy, which is 20 times my extension, which in this case is 0.75 squared over 2. And that is going to get turned into gravitational potential energy, which is 0.5 times 10 times the height, which at that point is 0.75. All right. Plus mv squared over 2. Right. So let's figure some of these values out. So what's that? That is 10 times 9 over 16 is 15 over 4 plus v squared over 4 times everything by 4, I suppose. 90 is equal to 60 plus v squared. I get v squared is 30. I get v squared is 30 at that point. All right. Now we get to do a bit of SUVAT because we're in free fall. S-U-V-A-T. We want to come back to where we started. Our initial velocity is root 30. Our final velocity, well, we should know is minus root 30. Our acceleration is minus 10. It's t that we're interested in. Yeah, how about we go minus root 30 is root 30 minus 10t. So t is root 30 over 5. So my total time t will be the total time it takes to go through your simple harmonic motion. No, we do actually need to figure this one out. We do need to figure it's not pi over root 10. The reason being, for my full simple harmonic motion, pi over root 10 would be all the way up to there, so we can't do that. So we've already got that bit there, which is quite nice, but we do need to actually figure out how long it takes for me to get from there to there. That's where this is going to come in. X is, what's the amplitude of my motion? Is 0.5 cos of root 40t. We want to figure out how long it takes for me to get over there. So that's minus 0.25 is 0.5 cos root 40t. Let's get you over here. Minus 0.25 divided by 0.5. Yeah. Shift cos of answer. Divide by root 40. I get that time there as 0.33. So it'll take 0.33 seconds to get up there, 0.33 to come down. So I make capital T 1.76 seconds. And there we have it. Sorry, a little bit of confusion on my behalf, but it's important to lock this down. So my simple harmonic motion is only true whilst the string is in tension. If I've pulled it down to 0.5, I'm going to want to ping simple harmonic motion all the way back up to here, which isn't going to work because in that last 0.25 meters, the string is no longer taut, and that's our problem. I was trying to be a little bit efficient, not lazy, efficient, and just whack the simple harmonic motion in, but from there to there is not, that last chunk there isn't simple harmonic motion. So you split it into motion from there to there, free fall, and then we're back into simple harmonic motion there. And that should do the trick. Let me know if you spotted any more mistakes. I really hope that made sense to you there towards the end, caught it. In the meantime, don't forget to like, subscribe, drop a comment, all that good stuff. Want to hear from you. I'm Nick, this was some maths. See you soon. The more eagle-eyed amongst you will have noticed that that is 4v squared. So v squared is that. So that's over 2, that's over 2, that's over 2, that's over 2. So that's root 30 over 10, I do believe, which gives us that 0.662306 plus root 30 over 10, 1.21. Is that better? Just fixed it. Don't mind me.